Hi guys, so for this video we'll be going over our final review worksheet number 2 in preparation for the final. Everything you see on these worksheets will be what you will see on the final, just the numbers will be changed. Okay, so you're not going to get these numbers on your final, but they'll be very similar. So if you can do these problems on these worksheets, you should have no problem on the final. So let's get started. Number 1, 12/16. We need to reduce that to its lowest terms. And so I can tell that both of these are even, so I know both will be able to be divided by 2. But if I find even a greater factor than 2, like 4, I can divide both by 4, and then that will give me 3 on top, and then 16 divided by 4 is 4. So that's how you do that one. Next is 18/24, and both are even, so I could guess that they will both be divisible by 2, but I'm going to try to find a factor that's a little higher than that. So I'm going to go for 6, because 6 can go into 24 and 6 can go into 18. So let's divide that by 6. 18 divided by 6 is 3, and 24 divided by 6 is 4. So we get 3/4 for both. Next is 35/40. I know that these both can be divisible by 5, so I'm going to divide both by 5. 35 divided by 5 is 7, and 40 divided by 5 is 8. Okay, moving down, rename or change the mixed number to an improper fraction. So here we have a mixed number. They want it changed to an improper fraction. I'm going to multiply my whole number times my denominator, and that's 16. And then I'm going to add 7, that's 23. So we come up with 23 in the numerator spot, and our denominator stays the same, 23/8. Okay, let's try one more. 4 1/3. My whole number of 4 needs to be multiplied by my denominator, that's 12, because 4 times 3 is 12. Add 1, that gives me 13 in the numerator spot, and I keep my denominator the same. The denominators always stay the same. Next one, 10 2/3. Multiply my whole number times my denominator, that's 30. 10 times 3 is 30, plus 2 is 32, and keep my denominator the same, 32/3. Next, we're going to change our improper fraction to a mixed number. So really we're just going to say 73 divided by 9 is what? Or we can say 9 times what equals 73, or comes close to it. 9 times 8 is 72. So I'm going to write an 8 as my whole number. My denominator stays the same in the same spot. So 8 times 9 is 72. But in my numerator, I have 73. So I'm going to add 1. Or I'm just going to put a 1 in the numerator spot. So 8 times 9 is 72, plus 1 is 73. We come up with that. So next, 42/10. 10 goes into 42 how many times? 4 times. 4 times 10 is 40, but I have 42 up here, so I have to add 2 more. 4 2/10 reduces to 4 1/5. So 4 1/5. 8 1/9. Okay. Next, we have a negative 26/3. 3 goes into 26 how many times? 8. Because 3 times 8 is 24. And if we add 2 more, we'll get 26. So 8 2/3, and that's a negative 8 2/3. Don't forget that negative sign right there. It's super important because I take off half a point for missed negative signs. Okay, next we have number 10, and it says evaluate the following expressions when x equals 2, y equals 6, and z equals 12. So they give you values that you can substitute your variables for. So here it says x equals 2, so we're going to substitute right here our x for 2, or 2 for x rather. So I might just rewrite that, and my x equals 2, and 6 divided by 2 is 3. So my answer is 3. Next we have 2y minus 12. Y equals a negative 6, so I'm going to substitute for y 6, okay, because y equals 6, substitute that there, 2 times y. When the number and the variable are together like that, that means multiply those two together. So 2 times 6 equals 12, and 12 minus 12 is 0. Next down here, we're going to have substitute a few numbers in here. So y squared, we know that y equals 6. So 6 squared minus x equals 2. 2 squared plus z squared, and z equals 12. Oops, I'm kind of running. So z equals 12, y equals 6, and x equals 2. Make sure you put those in correctly. Oops, I almost forgot my little squared up there. And so 6 squared, what that means, just as a reminder, 6 squared just means you multiply that base of 6 2 times, and that equals 36. Okay, 2 squared, multiply that 2 times, equals 4, and 12 squared, multiply that 2 times, 144. So go ahead and plug those values in. 6 squared is 36 minus 4 plus 144. Okay, so I'm going to go ahead and add and subtract here. 36 minus 4 is 32 plus 144. And then I'm just going to add my 144 to 132. And I get 276 as my answer. Okay, for number 13 and 14, they want you to use cross multiplication to test if each pair of fractions for if they're equal or if they're not equal. So this means they are not equal. That's an inequality, and this is equal. Okay, so the way we do that is there's a couple ways we could do it, but they want you to cross multiply. So 4 times 28. So you'll write 4 times 28, and then you'll write 7 times 17. So you cross multiply this numerator with this denominator, and this denominator with this numerator. Okay, and then you'll carefully multiply. 4 times 8 is 32, carry your 3. 4 times 2 is 8, plus 3 is 11. Here we have 7 times 7 is 49, carry your 4. 7 plus 4 is 11. So here we have 112 on this side and 119 on this side. So they are not equal. So it is an inequality. Okay, that's how you do those. Same with this one. 2 times 124. How does that compare to 3 times 84? And we'll multiply those. 4 times 2 is 8. 2 times 2 is 4. 2 times 1 is 2. 4 times 3 is 12. Carry your 1. And 24, 25. Those also do not equal each other, so they are an inequality. Okay, so for number 15 and 16, they want you to compare, and you're either going to put a less than, a greater than, or equal sign in the boxes here. Okay, a couple ways. There's actually a few ways that you can try to see which is less than or which is greater than. The first way I want to show you is you will set these two fractions and create in them equivalent fractions. So what I mean by that is you will take the 5 and the 9 in your denominator spot, and you will find the lowest common multiple, basically. So that would be, let's just guess, well, it can be 45. It will be 45. And so basically all you do for that is you just multiply the two denominators. Hopefully that makes sense. And then you say 9 times what equals 45? 9 times 5 equals 45. So then you multiply the numerator. 9 times 5 equals, or sorry, 7 times 5 equals 35. And then up here, 5 times what equals 45? 5 times 9 equals 45. So you multiply the numerator by 9 as well, and you get 27. So you have 27 45ths and 35 45ths. Which is greater? 35 45ths is bigger than 27 45ths. Okay? The next way I want to show you how to solve number 15, and this might be an easier way, is just to simply divide 3/5 and divide 7/9. So what I mean by that is 3 divided by 5 and 7 divided by 9. 5 goes into 36 times, you have 0.6, and 9 goes into 760, I'm sorry, 9 times 7 is 63. So this is going to be, I don't have to finish it. I can see that 0.6 is less than 0.7. So again, 7/9 is greater than 3/5. And yet there's just one more way I want to show you how to solve for this, and this is kind of fun. You will take, let me let the motorcycle pass by first. You will make two shapes, two exact shapes. They have to be the exact length, okay, and width. That's okay. And what you're going to do is you're going to divide this shape into 3/5. So it needs to, first of all, have 5 parts. So 1, 2, 3, 4, 5 in the denominator spot 5. And this one will have 9 spaces, we'll call them. So 1, 2, 3, 4, 5, 6, 7. Okay, well, we have 9 in there. I wish I would have made them a little bigger, but anyway, now we'll fill in 3/5. That's 1, 2, and 3. Just pretend I filled it in all the way. That's 3/5. Now we have to fill in 7/9. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And you can just see just in this diagram which one is bigger, and it's the 7/9 over the 3/5. That's another way you can solve for that as well. So let's look down at this one. So we'll just cross multiply for this one. Our numerator times our denominator here, 7 times 6 equals 42. And here 8 times 5 is 40. So which is greater? And also just remember, when you cross multiply here, make sure to put on the left side your very first fraction. So 7 times 6 will be your first one, and compare that to your second, not fraction, yeah, your second multiplication problem here, 8 times 5. So 42 compares to 40, and 42 is greater. Hopefully I'm not confusing you here. If you feel more comfortable using the division option, go ahead and do that. Okay, so for these next problems, here I'm just giving you an example. So when looking at the sequence here, 8 moving to the number 2, we would have to subtract 6. So 8 minus 6 is 2. And then to get to 9 from 2, you'd have to add 7. Okay? So hopefully that makes sense. You guys remember how to do those. Okay, so let's subtract 6 from 9. So 9 minus 6 is 3. Then add 7. 3 plus 7 is 10. Okay, let's move on to this one. 11 minus 9, or 11, 2 spaces or 2 numbers down from 11 is 9. So we're going to subtract 2. Okay? And then 9 to 18, we're going to add 9. So with that pattern, subtract 2 from 18, that gives us 16, add 9, and that's 25. Okay, I'll probably just give you one of these on the final. So here, 4 to 8, we're going to add 4. 8 to 7, subtract 1. So add 4 to 7, we get 11, subtract 1, 10. Okay, so now to find the greatest common factor, I'm going to show you all 3 methods, but just pick the one that you feel more comfortable with, okay? So the first one is the listing method. So I like to just come over here and list out all my factors of 8 and 10. So 1 times 8, 2 times 4, Can 3 go into 8? No. And then we're back to 4. So we're done there. Now, all the factors of 10. 1 times 10, 2 times 5. Does 3 go into 10? No. Does 4? No. Then we're back to 5, so we're good there. So now I'm going to look at all my factors here. We have 1. These are in common. Let's keep going. The 2's are in common. We're getting higher. 4, nope. No 4 over here. 8, nope, no 8. So our greatest common factor is going to be 2. Okay, let me show you the other methods. Prime factorization. So you'll just go ahead and write your numbers again and get all the factors of 8. So 2 times 4 is 8. I'll draw another box down here. 2 times 2 is 4. So these are all my prime numbers, down to prime numbers there. So now 2 times what equals 10? 2 times 5. And then, oh, actually 5 is a prime number. So we're done right there. So here's our factors of 10. And we can see that the greatest common factor is 2, because I only have 1, 2 here and 1, 2 here. I don't have another 5 over here. If I had a 5 over here, 5 would be my greatest common factor, but 2 again is my greatest common factor. Let's look at the trick method. Hopefully you guys remember that method. You're just going to take your numbers 8 and your 10 and what do I do? Okay, yeah. So you're going to divide the 8 into the 10 and you will get a denominator of 2. Okay, not that that's how you figure out the answer, but now you're going to look at, so you have a remainder of 2. So now let me just write these over again. So 10 and 8, and I'm going to put my 2 here, and if you remember, I'm going to put my lowest number of these 2 over here, and now I'm going to divide 2 into 8. Into 8, that goes 4 times evenly. So when there's no more remainder here, there's no remainder, that's when you say, okay, I have to stop, and I circle the last remainder, and that's my greatest common factor. So pick which way you like best and do it that way. Okay, let's look at 24 and 60. I think I'm going to pick the listing method here. I'll just do it one way this time. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and we're back to 7, 8. So we're back. Those are the factors of 24. How about 60? 1 times 60, 2 times 30, 3 times 10. Can 4 go in? No. 5, yes. 5 times 12. 6, yes. Times 10, 7, no, 8, no, 9, no, and we're back to 10. So now let's check out our factors. We got 1 and 1, 2 and 2, 3 and 3, 4, nope, no 4 over there, 5, no 5, here's a 6. How about an 8? Is 8 over there? No. 10, no. 12, yes. How about a 24? No. So 12 is our greatest common factor for this one. Now 42 and 70, I'm going to go ahead and use my trick method. Once the numbers get higher, you can use your trick method pretty easily. So I'm going to write my numbers with my higher number on the left and my lower number on the right. Now I'm going to divide 42 into 70. 42 into 70 goes 1 time. And I'm left with a remainder of 28. This number I'm going to put right here. I'm going to put this number right here, 42. Now I'm going to divide 28 into 42. 28 goes into 42 1 time. 12 minus 8 is 4, and 3 minus 2 is 1. I'm going to use this remainder and put it right over here. 14, and I'm going to take my smaller number of these 2 and put it right here. 14 goes into 28 evenly 2 times. Now I have no remainder, so I'll go ahead and circle this last factor here. So 14 is the greatest common factor of 42 and 70. Now go ahead and just list If you want to do the listing method, if you feel more comfortable with that, 1 times 42, 2 times 21, etc. Okay, and then find your greatest common factor that way. Okay, let's look at number 22 and 23. You'll list the multiples to find your least common multiple of each pair of numbers, then circle the least common multiple. So basically you're trying to find the least common multiple of 4 and 5. So go ahead and list those multiples. I kind of left 2 lines here. So multiples, remember, mean your answer. So 4 times 1 is what? 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. So list the multiples. 4, 8, 12, 16, 20, 24, 28, and then 5, 5, 10, 15, 20, 25, and so on. Now we're going to find the least common multiple. So try to find the least value here, the least number that is in on both lines here. So we don't have equal 4s, no 8s on this side, 12, and I find that 20 is my least common multiple. Okay, so 20. For this one, list the multiples of 8 and 10. So we have 8, 16, 24, 32, 40, and so on. And then for 10, 10, 20, 30, 40, and so on. All right, so I already noticed that my least common multiple in relationship to 8 and 10 is 40. Okay, so prime numbers. A prime number, if you recall, are opposite of composite numbers. So prime numbers have only 2 factors. So a prime number would be, like an example, would be 3 or 5 or 7, 11, 13. They only have 2 factors. 1 and itself. So these, 29 is one, 37 is another one, and so on. So your answer could simply be a prime number is a number where it only has 2 factors. Only has 2 factors. A prime number only has 2 factors. Okay? And I guess I just answered number 25. Write any 5 prime numbers. So here you go there. Okay, so number 26, write the prime factorization of 144 using a factor tree. So go ahead and write 144 on the top, make like a tree looking thing, 2 branches, and then think of your 2 factors that will give you 144. If you can't think of what they are, you can always start off with 2 and work your way down. So I'm going to try to find 2 factors that are pretty high. 12 times 12 equals 144. And then I'm going to branch out. 4 times 3 equals 12, and 4 times 3 equals 12. Once you get prime numbers, I want you to circle them. So 3 and 3 are prime numbers, but 4 and 4 are composite numbers, and you can still keep factoring that out. So 2 times 2 is 4, and 2 times 2 is 4, and now I have some prime numbers here. Also, so you will count your numbers. So 2 has 1, 2, 3, 4. So you'll write 2 to the 4th power times our number 3 here. There's 2 of them, so you write 3 to the 2nd power, or 3 squared. Let me just, so that's your answer there. That's how I want it written out. But just remember up here, I forgot to say that 2 is also a prime number, because you can only multiply 1 times 2 to equal 2. Okay? All right, well, that's it. Hope you guys are doing well. Let me know if you have any questions.